So, hello guys. Today for this week, we are going to see an interesting project. Okay. So, today we are going to see about how to generate a match report. Okay. A cricket match report based on the commentary data we have. Okay. So, we have CrickBuzz, CrickInfo, and we have a lot of people like that, right? Like they do match commentary, and then finally they do generate the match reports. So now what we'll do is, using artificial intelligence, based on the commentary data we have, we can generate match reports, okay, about whatever happened in that match. So this is a kind of a prototype which shows that AI has the potential to do this task. Okay, so why I'm saying it as prototype, let us see that in some time. Okay, so here is a sample of what our output will be. Okay, I've already done this project sometime before, so but we'll do it in live from scratch again. Okay, so here I've given some input. Okay, so here you can see the whole match commentary is like not it doesn't look like the whole match commentary, right? There is some reason behind that, and I'll show you what. Okay, so this is some match report which was generated, which makes some sense. Okay, like it is not contradicting itself. It is clearly showing that India has won the match, and here also you can see Virat Kohli has won the match for India. So Virat Kohli 71, okay, and unbeaten 71 has led India for a 6 wicket victory. So we can say like it was able to learn something. Okay, so let's see how to do this kind of an application. Okay, so uh, before generating the model or writing the code for the model, it is very important for us to process the data and collect the data, right? So first we'll see where we get the data and how to process it. Okay, so here a huge shout out to Sachin Muttapanavar. Okay, from his GitHub only I have got the commentaries and reports data. He has published a research paper, or rather a thesis paper. Okay, in which he has shown that a context commentary can be converted into a match report. Okay, but what he has done is he has kind of scraped from ESPN Cricinfo, it seems, and we are just going to use the scraped version. Okay, we are not using the processed version. So here you can see he has lot of files, right? Like rather than this final Excel file, here he has done some processing which we won't follow. Okay, we'll do something different from our side. So we'll be taking this CSVs alone. Okay, and on top of that we'll do some processing to minimize the data, and I'll show you what all we are going to do right now. Okay, so let's jump on with the data processing first. So yeah, here you can see, right? We have different folders here, data, where I have commentary and reports separately. Okay, so first what we are doing here is we are importing pandas and glob. For those who don't know about glob, it is just a Python package which will help you to do file operations. Okay, so first what we are doing is we are going into this file commentary and we are seeing what are the files inside that. Okay, so totally there are around 501 files. So similarly we are doing the same for reports. Okay, so that is what is happening in here. So once that is done, I'll show you what is happening here. Okay, so let us take a sample here. Um, commentary underscore one dot csv. Okay, so what is happening is when you take the kind of the path, what will happen is it will be data slash commentary double slash commentary one dot csv. Okay, so first we are taking the file name alone from that. This results in your file name, and from there we need the match number which he has encoded 1 to some n numbers. Okay, so we are taking that file number, so this will return in 1.csv. Okay, because if we split this, right, commentary, and it will be on 1.csv because we are splitting it based on underscore. So again, when we split it based on dot, we'll get file number. Okay, so like that we are getting the file numbers of commentary as well as report. For report we'll do something different, because what has happened is there is no kind of delimiter. So what we are doing is, instead of doing this split, we are replacing report as a kind of an empty string. Okay, so similarly you can do this here as well. Commentary underscore can be replaced as an empty string. So similarly you will get the file names. Okay, but here you can see there is a difference in the file number, right? Here it is 501, this is 592. So what we'll do is, we need to know which are all which matches data are all there in both commentary as well as report. Okay, so what we are doing is, we are taking a set of commentary as well as report. Okay, because it has different number of functions which we do in our normal math calculation. Okay, normal set, which we have learned in a lot of our higher studies. Okay, in that there is a function called intersection, because we need matches which are there in both reports as well as commentary, which means like we need to have commentary as well as the match report of any matches, then only we can use that data. Okay, for that we are taking the set of these and intersecting these. Okay, so that will result in matches which you have both commentary as well as report, and we are making a list out of it. Okay, now by this we can know that, okay, we have kind of our let's say files to read. Okay, so now again we are doing the similar split here, but what we are doing is, we need to know which are all the files we need to read. Okay, paths, we know which are the matches we need to read, but we need to know the file paths, right? So for commentary we are running this. Okay, so similar split will happen, and we'll have this number here, right? We'll check if this number is there, if the match number is there in this to read fno list. Okay, so similarly we will do for reports, by which we will see like, okay, this is true. Now coming to the very important part, where if you take this reports, right, like report, or rather the commentary files, and if you tokenize it, okay, in default, by default, okay, you will get around 9,000, 10,000 tokens, because it is a huge data. Okay, you will have records of at least, let's say, mostly it would be T20s, so 240 balls, let's say they are getting out in 200, so 200 balls for 200 lines, plus there will be some comments of the match, pre post. Okay, let's take 10 instances of that, so it will be 210 lines, and let's say in each line will have around minimum of 10 words, which is so less. So then also it will take 2100 words, which is around 3000 to 3500 tokens, and we can't process that kind of a data. We don't have the computation. It is always good to have that kind of long sentences, and to this use case it is precisely needed to have that kind of huge input, but we don't have the computation for that. So what I've done here is, first I'm just going through the comments, okay, line by line. I've just read the file here as a data frame, and I'm parsing through the data frame. I've set account variable. I'll just say you why. Okay, let's not think about that right now. First, we'll have everything as lower, because if you see in commentary, right, some people might keep everything in uppercase and some people might keep everything in lowercase, so it differs from person to person. So what we are doing is, we are making everything in lower, because when you match an ASCII character of small a to capital A, it is going to give false. Okay, so now what we have done is, we have made it as lowercase. Okay, so first what I'm checking is run, the word run there in the comment. If it is not there, then well and good, go to the next condition, where check if it is the first line. Okay, if it is the first line, we need it because usually the first line starts with the toss or else they give a match preview or something like that. Okay, so that is very needed. Okay, it will give a huge influence. Let's say if it is a T20 final, they would have given a huge hint about what is going to happen rather than a hint like a hunch of what will happen, and that will be very useful for match reports. Okay, so we are taking the first line as well as last two lines. Okay, that's why we have this count variable here. We need the first as well as last two lines. If these are all satisfied, we'll append this to the commentary input list. Okay, we'll be going again line by line. Let's say it is in the 10th line. What we need is we don't need information about extras. Okay, that is not very important. Yes, it is important to some extent, but it is not that important than others. Okay, so what here is we are taking by we say, right? We take by, wide, extra. If these are all in the comments, we won't use it. So that's why we have given not in. Okay, we don't need this kind of extras data. All we need is out there in that chain, okay, which is the lower variable. Why I've given out here? Because at times what will happen is in a simple stuff, it was wide outside of like that it will be given. Okay, so that's why we are uh, checking first and then making out. Okay, so similarly we are seeing for wicket because sometimes we mention it as out, sometimes the people mention as wicket. Okay, so we are taking if let's say like uh, the instances which we think of as very important is the comments from people about the match or what is happening in the match currently. Okay, a summarized one, like let's say like in the mid innings break they say something, right? That kind of comments which is very important for us, and pre-match post-match comments and all. And then the next thing which is important is wickets, because wicket instances say about what has happened. Usually they say like the man has scored this much run, he has got out, or something like that. Okay, so wickets is very important. Then the third important event is sixes. Yeah, fours is also equally important, but fours will have lot of data instances and we can't afford for that. So what we're doing here is if these conditions matches and we have some again some random data which doesn't have run, uh, we are just leaving it to system whether to choose it or not. So we are just giving 0 or 1. If it is 1, we are just going to use it. Okay, so if it is a 6, again like we can't say this is important 6 and this is not important 6, but we can't have all the sixes as well. Trust me guys, I've tried lot of experimentation to process this data to a smaller count. Okay, and this is the exact thing you'll need. We'll take 1 by 4 of 6 instances, and six, I mean like instances in which 6 has been given. Okay, so when we do these all, we'll get a list of comments, okay, of the match. So similarly for report, there is not a lot of processing needed, so you can see like it is kind of pretty good actually by default. But there are lots to do after this project as well. I'll say uh, what are the future works which we can do after this project. Okay, so these are all two functions, and then we are reading these, and then we are making a data frame out of this. Okay, so in this we have 465 instances, and that 465 is again stored as a CSV as well as a Parquet file. Why a Parquet file? Um, I guess I've specified in one of my videos where CSV is always huge. Okay, like the size it consumes is huge, and Parquet is very less. So let's say here also, like the if CSV file is 6 MB, it will be around 3 MB for Parquet. Okay, so that's why we have done this. And here you can see we are tokenizing it. Okay, and we have made some plots to check around, like most of the data will be covered on at 1000 and 1200. That's what this describe function here does. Okay, 1200 is a good amount. Okay, so what we'll do is we'll have this 1200 as our like max length, because we are covering around 75% data. And what will happen for the rest of the data? It will be truncated. Okay, that we'll usually do in tokenization, that will do somewhat later. Okay, so now we have like what we need to do. Okay, the data is ready. Okay, and guys, I've just given a walkthrough of the code of what we are doing in this data processing. And if you don't understand, no worries, I've given the Telegram links in the comment section. Okay, uh, as well as in the description it is given. So in the description, you can check the Telegram link and then group link, and then join the group, ask the question, or even from in Telegram, you can find my name there. You can personally even message me regarding this or other any other NLP projects or any AI projects. If you want some consultation regarding that, you can just ping me in Telegram. Okay. So let's go on with the project right now. Okay. Or rather, code of the model. We are already doing the project, right? So let's start with the coding. Okay, so here, let's make it as cricket news to cricket match report. Okay, so yeah, uh, we have our notebook instance ready. In that first we'll connect the runtime. Okay, just yep. For this we'll need GPU, right? So we'll enable GPU and we'll save it. Okay, so it is showing connect. We'll connect to the runtime, and until then what we'll do is we'll mount the drive first here. Okay, let's see, it is mounting. And guys, you might not get a code cell here, but sometime you might get a code cell. And just run it, and then it will ask a permission to connect, and then you can connect it. Okay, so yep. Now what we'll do is we need to first upload. Okay, so where it will be, um, it will be in this. Okay, so we are just uploading it, and until then, like usual, we'll install the dependencies, which is the common ones right now: transformers, data sets. I guess we'll need accelerate, theft. Okay, I don't think any others will be needed right now. Okay, so now it is getting uploaded, right? Yeah, it's uploaded. So we'll run this. And next step, rather than doing it later, first we'll take our API token from Hugging Face and we'll instantiate here. Okay, so yep, don't forget to have a right token, log in here. Okay, so first what we'll need here, we'll need a dataset class, right? So what we'll do is we'll do the imports required. Import pandas spd. I don't think we'll need it. Okay, first let's have from data sets. Okay, um no, we'll need it. Import pandas spd. from data sets, import load underscore dataset, and then we'll need auto tokenizer from transformers import auto tokenizer. Okay, so we'll have a class here, class config. Uh, for those who are watching this video for the first time in my channel, uh, I'm just giving a thing why this class and all I'll keep it in small, because like you can have a separate file called config and paste all these constants which we will have here in a separate file called config, and then do an import config. Okay, for those guys who have been watching me for some time know why I am keeping this name like this. Okay, so we'll have these variables first for data class, right? So data path, model, CKPT, these are all some conventional ones. Model, CKPT, and then we'll need uh, source column name, source column equal to target column will be needed. Then we'll need source max len and target max len, followed by this. I guess we will need label pad token ID. Other than this, I don't think we are going to need anything. Okay, so we have all of these here. I think these are all not string, so we'll have it here. So for data path, first we'll copy this, we'll paste it here. For model, we'll search plan T5 large. And for those who are watching me repetitively might think like, why are you always going for Flantify large? I'm just a big fan of Flantify. It gives great results. Okay. Next, for the source column name and the target column name, the source column name is commentary highlights. Okay, and the target column name is match report. Okay, why I have given it as commentary highlights, you know, right? We are not taking the whole commentary, we have just made some uh, important lines alone out of it. Source max len 1200, like you have seen from there, right? And target max len will have as 256, and label pad token ID is 100 minus 100. Sorry. Okay, now our configuration required for dataset is ready. Okay, we'll now create the dataset class. Class cricket commentary report generation, a huge name, dataset. Okay, we'll make init here. Okay, self dot data underscore path equal to config dot data underscore path. Okay, self dot model underscore CKPT equal to config dot model underscore CKPT. Okay, self dot src column equal to config dot src underscore column. Okay, self dot target column equal to config dot target underscore column. Okay, then we'll need source max len self dot src underscore max underscore len equal to config dot src underscore max underscore len. Okay, then for target max len we'll have self dot tgt underscore max underscore len equal to config dot tgt underscore max underscore len. All right. So finally, we'll need the tokenizer. So we'll instantiate that also here itself. Self the tokenizer equal to auto tokenizer dot from underscore pre-trained self dot model underscore ckpt. Okay. Now we have instantiated all those which we need here. Now we'll create a load data function. Okay. So we'll have df equal to pd dot read underscore csv. In the previous video, I've also shown you how to load using load data set. Okay. So this time what we'll do is rather than this, we'll load it as a pandas data frame and then we'll convert. Okay. I'm just showing you different varieties. We'll have self dot data underscore path. Okay. So data will be equal to data set dot from underscore pandas. This will create an arrow data set from your what can I say, pandas data frame. Yes. So we'll pass the df here. Okay. So now that is done. So once that is done, we'll get the data itself, return data. Okay. Next, what we'll do is we'll create a pre-process function just to do tokenization. Okay. Self comma example. Okay. I guess we'll need padding and truncation also here. Padding equal to max underscore length. We'll pad to max length. Okay. Truncation will be true. Okay. Now that is done. We'll do it here also. Self dot padding equal to config dot padding and self dot truncation is equal to config dot truncation. Okay, so let me have it here. Okay, now that's looking good. Okay, self comma example. What we'll do is first we'll need model underscore int, which will be equal to self dot tokenizer of example of self dot src underscore column. Okay, then we'll need max length. Okay, so max length will be equal to self dot src underscore max underscore length. Okay, then for padding we'll have padding. Oh, sorry, self dot padding. Then for truncation, again we'll have self dot truncation. Okay, or is it showing error here? Expected is to what? Guess this is correct. Yep. Collab is slow. Next we'll have labels. Okay, which is the target one. Okay, the target which is here match report. Okay, again we'll tokenize the match reports. These are all some things which we have now get used to, right? Like we are doing this in every video and every project right now. Self dot target column max underscore length will be equal to self dot uh, target max length. Okay, padding will be equal to again self dot padding. Same goes for truncation. Okay, okay, now this is done. Now we need to replace our padding tokens, right? Labels of input id is equal to, we'll have a list comprehension here, labels if uh, sorry label uh, for label in label of labels of input underscore ids. Okay, label if label is not equal to self dot tokenizer dot pad underscore token underscore id, else minus 100. Okay, now it looks correct. Okay, um, if we face any issues we'll solve it later. Now we need to add this into our model input, right? So model input of labels will be equal to um, labels of input underscore ids. Will return this, return model underscore in. Okay, now our dataset class is actually ready. Okay, now let's just make a wrapper function, kind of wrapper function, so that we can just call this function for everything. Okay, first we'll need data, right? So data will be equal to self dot load underscore data. Okay, so once that is done, we'll get our data which we need to train. So once that is done, we'll do tokenization, right? So we'll have it as tokenized underscore data, which will be equal to data dot map of what we'll need to map. We'll map preprocess function self dot preprocess underscore function. But here, rather than unusually, we'll have batched equal to false, because uh, usually batched equal to false now recently has been returning error when you have sequences of long variations, like one sequence is of 8,000 tokens and another it is of 1,000, something like that. Okay, so here we are making it pass one by one. Okay, so batched equal to false. Then uh, other than that, everything is very conventional. Okay, remove underscore columns is equal to self sorry data dot column underscore names. Okay, will return this, return tokenized underscore data. Okay, now this is fine. Now rather than the conventional way where we have a single class for training, right? Here what we'll do is we'll have a separate class for utils hereafter. Okay, because it is easier to manage whatever we do with Lora being in the picture. It is convenient to manage with a separate class, so we'll have a separate class for utils. Import from Peft, import get underscore Peft underscore model. Then we'll need LoRa config. Okay, I think these both will be needed from there. As far as transformer is concerned, from transformers, we'll need a data collator for seek to seek. Okay, this will be needed, and then a trainer maybe. I think training arguments alone will be needed. We'll have trainer for a separate class there. So we'll copy the class name. It is huge. Utils. Okay, utils is, as the name suggests, utilities. uh, Guys, why we are doing it as separate code cell and we are having classes is because, like, you can have these as separate files and then easily managed. This is because, like, a lot of people won't have computation, so we are doing it in collab. So if you have a good computation, let's say like a server, a GPU server, then what you can do is, what I suggest is, rather than using it in Jupyter Notebook, have these as a separate files and then run it as a single script. Okay, so that will help you a lot. Self, I guess this is here. What all we'll need? I think we'll have a pass here. Okay, whatever we'll need to define, we'll define it here. Okay, so here, first everything related to LoRa will be needed. So LoRa R will defaultly define it here itself 8. Okay, we'll need LoRa R, and then LoRa alpha, which will be equal to 16. These are all some conventional things which we have done in previous videos, like chatbot, by using Flantify, as well as even in Llama we have used LoRa, but it is QLoRa because we have done it under quantized LLM, right? So here you're doing it on LoRa again. So LoRa target modules will focus on query and value. Okay, so then we'll need a dropout. LoRa dropout will be equal to 0.1. Okay, and then finally we'll need LoRa, I guess, task type. Yes, that's what we were missing. Task type, which will be seek underscore to underscore seek underscore elm. Oh, mistakes. Because this is correct. Yes. Now we'll do LoRa first and then we'll come again, okay, with the others. Self dot LoRa underscore R will be equal to config dot LoRa R. Copy this, paste it here, have a tab. Okay, so here self dot LoRa underscore R equal to config dot LoRa R. Okay, self dot LoRa underscore alpha equal to config dot LoRa alpha. Self dot LoRa underscore target underscore modules will be equal to config dot LoRa target modules, and then self dot LoRa underscore dropout will be equal to config dot Lora dropout. Then task type, right? Self dot Lora underscore task underscore type will be yes. This looks good. Now we'll create def Lora underscore model of self. Okay, but here we'll need a model param. Okay, so what we need to do is first we need to create a peft config. Peft underscore config is equal to uh, I think rather than peft we'll have Lora. Lora config is equal to Lora config. Okay. Oh, yeah. We'll have r is equal to self dot Lora underscore r. Um, target modules equal to self dot Lora underscore tgt underscore modules. Then we'll need Lora alpha, right? Self dot Lora, sorry, Lora underscore alpha is equal to self dot Lora underscore alpha. Lora underscore dropout is equal to self dot Lora underscore dropout. Okay. And other than this, we need bias, which will be none. Okay. And then finally, we'll have task type. Task underscore type, which is equal to self dot Lora underscore task underscore type. Okay, so now our Lora config is ready. Now we need to get a model based on this Lora. Okay, so what will happen is we'll have it as Lora model. Lora underscore model is equal to get underscore peft underscore model of our model, which we will be sending from our main training class. Okay, which will be a quantify here, and then our adapter config, which for which we use Lora. Okay, Lora underscore config. Okay, so we'll return this. Other than this, conventionally, what are all we have done is that first we'll also print one thing here. Lora underscore model dot print underscore I think trainable parameters. Yes. So we'll need a data collator. We'll have it as string data collator. Okay, so we'll have data underscore training data collator will be equal to data collator for seek to seek. We'll need tokenizer, so we'll maybe pass this also from there itself because uh, rather than instantiating here, it is better to call from there. Okay, so I guess we'll also need model, so we'll have those here. Tokenizer is equal to tokenizer model equal to model, and after this we'll need label underscore pad underscore token underscore id, which we have done here also, right? um, Here we should have it as self dot label underscore pad underscore token underscore id. Okay, Um, we haven't even called it here. Okay. Self dot label underscore pad underscore token underscore ID is equal to config dot label underscore pad underscore token. Okay. This is good. Yep. So we'll have that also here. Self dot label underscore pad underscore token underscore ID is equal to config dot label underscore pad underscore token underscore ID. Okay, we'll call that here self dot label underscore token underscore ID. All right. So after this, what we'll need is pad to multiply. Okay. For this, we haven't defined. So what we'll do is we'll have it here self dot pad to multiple. We'll copy this. We'll paste it here. Should be equal to config dot label, sorry, pad to multiple. Okay, so I'm just copying this and pasting it here, which will be equal to 8. Okay, so that is done. Okay, now our data collector is ready. We'll return this as well. So our data collector is also ready. Next, what we'll need is we'll need our training arguments, right? So that is required next. So for training arguments, we have done this so many times. So I'm just copying one of our previous functions. Okay. Okay. Um, but don't worry, I'll just give a walkthrough in a minute. I'm just pasting the params. Okay. Okay. Um, Now, what all we have used? Output directory where the model needs to be saved, or what is the name of the model. Okay, and then our batch size, training batch size. For learning rate, um, we have given 2 e minus 4. For batch size, we have given 1. For model out directory, we have just given a name, and then num train epochs. Here, what we have given, I guess 3. Yes, okay, and then next we have a logging directory where we need to log store the logs. Okay, for logging strategy, when we should log some train loss or validation loss. Here we won't do validation, but for training and all we'll do at end of every epoch. So similarly we'll save the models at the end of epochs. Okay, so how many models we need to save? Only one checkpoint. Okay, at how many every epochs is happening, we'll just save the latest checkpoint. Okay, finally we'll push to hub also. So our arguments is also ready. Okay, it's getting run. Okay, that's good. Now we'll move on with the training part. Okay. Um, for this we need some transformers import auto model for seek to seek LM. Okay. Then we'll also need auto tokenizer. Sorry, auto tokenizer. We'll have this as trainer. Okay. So in it, what all we need to do? We'll have pass right now. Okay. We'll need a function called prepare underscore training of self. Okay. We'll pass this also. We'll have a trainer function def model underscore trainer of self. We'll need def model save train save push to hub. We'll need these functions. This is kind of our boilerplate. Okay, and this will work. We'll have a pass here. Okay, so for init, what are all the things we'll need? We'll need the classes which we created right now. Okay, first self dot data underscore module will be, I'll keep it as dataset module. Cricket commentary report generation dataset module, which is yes. Now this is fine. We'll need the utils module self dot utils underscore module, which will be equal to cricket underscore commentary generation utils module utils. Okay, so that is done. Next we'll need the model checkpoint name, right? So self dot model ckpt, which will be equal to config dot model underscore ckpt. Okay, we'll rather have it here. Then we'll need the tokenizer as well as model. Before that, we'll also define the model out directory. Self dot model out underscore directory is equal to config dot model underscore out underscore directory. Why this is needed? Because we need to have a safe path here for this function, right? That's why. Now we'll create the tokenizer. Self dot tokenizer is equal to auto tokenizer dot from underscore pre-trained of self dot model checkpoint. We'll copy this, we'll paste this, we'll copy this, paste this here. This is model. Okay. So now, right now we have the base. Okay. First, what is needed? We'll need the data. Okay. So self dot train underscore data will be equal to self dot data underscore module dot what is that gen data something. Yes, gen data function will be needed. Okay, so once that is done, we'll have our train data. So um after that we'll need data collator. Self dot data underscore collator will be self dot utils underscore module dot train, what was it, data collator of self dot model comma self dot tokenizer. Before this, we'll also need the fifth model, right? That is needed. Okay, so what we'll do is we'll do self dot Lora underscore model, which will be equal to um, self dot train underscore utils underscore module dot Lora underscore model of self dot model. So this is done. Okay, we have our model, we have our collator, we need training arguments. Okay, so self dot um, training args, which will be equal to self dot utils underscore module dot training args. Okay, so that is done. So we'll have our Lora underscore model dot use config dot use underscore catch equal to false. Okay, now we are ready for our training. As far as trainer is concerned, we have already done a lot of these, so I'm just pasting it again, like similar. Self.train data is there. Okay, we'll have just train data set, data collator. Here are training arguments, we have our model. Okay, so everything is there. By this, we'll get our trainer. Now, for uh, getting into the model training process, trainer will be equal to self dot model underscore trainer. Okay, from this we'll get our trainer, right? So next what we need to do is trainer dot train, trainer dot push underscore to underscore hub function. Now this will push only our what can I say, our adapter model, okay, which is our LoRa model. We need to save everything, right? So what we need to do is trainer dot model dot base underscore model dot push underscore to underscore hub. Okay, so this will push our base model. Okay, so we'll also push our tokenizer self dot tokenizer dot push underscore to underscore hub. If you want to save your local, like if you have your own, okay, I didn't import it. Seek to seek trainer. Okay, so if you want to run this in local, let's say you have your server and then you want to run this there. So what you can do is you can also run save pretrain function for all of these. Okay, for tokenizer, for trainer.model.save pretrain to save the adapter model. Okay, and then trainer.model.base model.save pretrain to save the your base model. Okay, so once that is done, you'll have your folder here, then you can just download it and then use it, like I said, copy it to drive and then use it. Okay, so now actually our training script is ready. Okay, so finally to run this main trainer, let's call it model trainer is equal to commentary. My voice not even coming. Okay, better not wait. Okay, model underscore trainer dot. Okay, now training is started. The model from the hub is getting loaded. uh, guys, like I said, I've already done this. I'll also show you what would be the result of this. Okay, like how the training would go, things like that. All right. Okay, I'm also opening that because if we wait for this to run, it will take some time. uh, we'll see how to inference this in this video itself for this project. Okay, I'm just opening that notebook here. Once here the training is started, it will replicate the same which is here. Okay, and you might see some kind of variable changes, name changes, and this save pretend changes also will be there, but it is the same. uh, Training arcs, where commentary generation methods. So okay, it is set training arcs. All right. Mhm. My mistake. uh was it loaded, or yes, no, we can run this from here itself. So I'm just showing, okay, so what is happening right now. Let it train. Okay, so once that is done, we after running it for three epochs, we got 2.77 loss, which is fine. Okay, which is this is a small model. We have also uh, done Lora on top of it, which is reducing the params even more. Okay, but we have very less instances, less than 500. So this is fine. Okay, this is not a very wrong one. Full determinism. Okay, just give me a minute, guys. Training arcs. Didn't I call the function? Yes. This is one of the issue which I have faced in my previous times itself. Okay, so what will happen is the error won't make any sense. Okay, this would have been called called as an attribute rather than a function. If you call this as function, it will work. I guess we'll need to do everything from first. It's already 12.2. So let me give you a walkthrough of the inference script right now. Okay. So why I'm giving walkthrough, because this is almost similar to our chatbot. Okay. The core. So what we are doing is first we are importing Streamlit as st. All right. So from peft we are importing peft model and peft config, which is very needed because that is our model, right? Peft model. We are not using the base model. So then we'll also need auto model for seek to seek LM and auto tokenizer. And now to explain the elements, uh, just give me a minute. I guess this is training right now. Okay. So what we'll do is we'll see this. All right. So we have our title here. We have our subheader. You would have seen there, like a title and a subheader would be there. For that you can use st.title function and st.subheader function, and then we are doing st.catch resource. Uh, do this so that always your model will have been loaded by default. For each call it won't get loaded again. Okay. So here like you can see here, right? Wasn't crick com to crick news. That's where I have stored while I trained previously. Okay, this I'm loading it from hub. Like you can see, you can't see that directory here. That's why I said save pretend might not be needed. We can also load it from hub. But when you are doing it for a company, you can't have it in hub. That time you can do save pretrain and then load in the similar way. At that time, what you can do is this parameter should be removed from transformer equal to true. Okay. Based on this, we are loading the model tokenizer and then we are making the peft model. We use this get peft model, right? Instead of that, we are using this class, all right? And then we are converting it to CPU so that we are doing inference alone, right? So in inference, what we are doing is we are getting the input sentence here in a text area. Okay, so once that is done and I click the button called generate news, what will go, it will go to this function where I'll pass the model and tokenizer. First the inputs get tokenized in the similar way, like max length 1200, padding and truncation, everything will be there, and then outputs will be generated. Okay, based on this we'll be passing this input IDs to the model and then it will generate. We are doing a beam search here where the number of beams is 5, and then no repeat ngram. What it will do is ngram means that how many words, so it will just see like 3 words. Let's say Vasant is YouTuber. Okay, it will make sure that Vasant is YouTuber, the 3 words again doesn't repeat, though that's what no repeat ngram size does. Okay, so by this we'll generate the tokens. Okay, so once that is done we'll decode it and then we'll get the sentence, and that is printed here. So this is how inference occurs. Okay, so if you have any doubts again, just let me know in the telegram or else even in the comment section. I'm very more than happy to explain even it in the comment section. Okay, so let's see if the training is moving. Oh, what is going on here? Clean file training arcs.bin. I guess it is better to, like, do everything from starting. Oh yes. Um Sorry. Let me go to my Hugging Face profile. uh, Better I change the ID. Yes, that is the issue, I guess. So what we'll do is we'll rerun this. Okay. um I'm just gonna stop this training right now here. Okay, so where is it? I'll just have it as news. Okay, uh we'll do restart runtime. Okay, we'll need this. Okay, no tokens are added. So as far as inference is concerned, I've also shown you previously, right? It is working. Okay, so you might think, man, how to do inference, like for us, like what are the inputs? For that, you can see there is a file called inference samples.txt, right? I've given two samples. Both are from Indian teams commentary, which is processed. Okay, so you can use this itself. There is no problem. It is working. Okay. Uh, Once the training is completed, I'll also show how to improve the performance of this. Okay, we'll see how the training is going right now. Okay, the model has got instantiated. That's good. Um, just give me a minute, guys. So yeah, guys, it was a small error. What happened was I made a wrong function call. I'll also show you what I did. It was a very silly mistake. Instead of passing tokenizer here and model here, I passed the opposite, model here and tokenizer here. That was a mistake which I did. Okay. Um, Now the training has started. Um, I'll just stop the training here because like I've already shown you uh, what is the result, right? Uh, I will share you this notebook. You can run it, and if you run into any error, you can just ask me. Okay. Um, as far as inference is concerned, I've also shown you that how we can do inference. Okay. Now coming to the future works. Okay. So here, coming into the future works, what we can do right now is that first thing is we need to collect more data. Okay, so for that we need to scrape it from either Quick Info, QuickBus, or any other news source like that. Okay, we need to collect more data. Next, if we find a better way to process the data, for now I've just thought of the best way possible from my side, where that we can consider some six wickets and some general comments, which is very important. But if there are some other information which we can include, and then we can exclude some information which are already available, that is also fine. We can also do that. Okay. Other than this, we can train with some different models as well. Okay, there is Flantify base variant, which is very less in size. We can also perform a full fine tuning there rather than doing by Lora. Okay, because it is a very small model. That is another experimentation which is possible. I'll maybe create future works txt here. Okay, future works dot txt. Okay, so we'll need to do increase the data. Okay, increase the data available at least to 1000, at least to 2000, something like that, at least till 2000. Okay, next, find if there is some way to process the data better than current way to capture more information efficiently. What do I mean efficiently? Because right now we don't have computation, right? So similar to 1200 tokens, we need to capture more information. Okay, so next, increased computation power. Okay, so if you have like good system, uh, run it for longer epochs. Okay, run it for longer epochs, then experiment with some different models as well. Okay, so these are all some of the future works which we can do. Okay, so uh, now, yeah, so what I'll do is let me wait for the training to complete. Okay, I'll wait till the training completes, and then I'll upload this notebook into the GitHub along with those files which are already available. Okay, and yep. So right now you can see, right, we have a good prototype, very good prototype, guys. Like this is a great starting point to use the power of AI in cricket. There are some other use cases which I have planned, and if you do have any use case from your side, just let me know in the comments. Maybe even we can work together on that. Okay, so yep, I hope you all like this video. If you like this video, please click the like button, subscribe to the channel. Okay, because most of the viewers are not subscribed generally. The YouTube analytics shows that 20% of my users have subscribed to me and 80% have not subscribed. So if you do like the videos, please do click the like button. It's free. Whenever you feel like I don't like the videos, you can unsubscribe then. Okay, so that's completely your wish whether to subscribe or not. And then yes, share it with your friends, whoever likes cricket analytics or AI NLP. Okay, this is a merging of lot of domains. Okay, uh yep, so that's it for this video. So I'll see you all in the next video, most probably, which will be Wednesday or Thursday. Okay, so that is a small shout out for, because hereafter most probably will be uploading 2 videos a week, because there are lots which I haven't planned. Like we'll be covering some research papers, we'll be covering like I said, PEFT, TRL. There are lots which I will cover in the next upcoming weeks. Okay, so to cover that efficiently within smaller period of time, we'll do 2 videos per week. One will be on Wednesday and another might be on Saturday or Friday. Okay, so yeah, that's it for this video, guys. I'll see you all in the next video. Until then, cheers.